So next part, how does it work? Generally, we rely on the sun to heat the planet. We're close to a solar system. We're probably closer to a solar system than a geothermal system because we need the sun to warm the earth. If the sun did not warm the planet, this wouldn't work either. The earth is a big radiator. It's a big battery. Where do animals go in the winter when they're cold? They burrow holes in the ground. How deep does a groundhog dig? Not 1,000 feet, a couple feet, okay? Where do animals go in the summertime when they want to get cool? They scratch the surface of the earth, lay in the cool soil. It's like my dog, keeps digging underneath my deck, keeps getting deeper. So, shallow earth, the earth is a radiator. Well, generally, about half of the energy from the sun ends up in the earth. The other half is either absorbed by clouds or reflected away, but generally half of the energy is in the earth. That's the energy we're trying to tap and bring into your house, okay? Question usually comes up is what's the temperature of the earth? Well, depending on where you look in the United States, it generally runs from about the mid-40s to the mid-70s, but it really is insignificant. The ground source heat pump is designed to work with incoming water as low as 20 degrees or as warm as 120 degrees. So it's really an insignificant number, but it is heating and it is cooling. Because all we're going to do is push heat. We're going to push it one direction or the other. Thermodynamics of a ground source heat pump, which is pretty much the same as the heat pump that you have right now at home. Because you have one of these, right? You have a refrigerator, you have a heat pump. A couple laws of thermodynamics. You live with them every day and don't stop to think about them. Number one is cold. There is no such thing as cold. Cold is just a word. Define cold. Define cold. There is no definition. The definition of cold is lack of heat. How do you make cold? You can't make cold. It's impossible to make cold. You can only remove heat, but you can't make cold. Think about your freezer at home right now. It's probably set on 0. Where did it get its cold from? It didn't. It took the heat out. When you walk by your refrigerator, that's why you feel heat. You don't feel cold. It pumped the heat out of the box. Live with it every day. Don't stop to think about it. That's one law. Second one is energy flows downhill. Energy goes from high to a low. That's how the atmosphere works, right? You see highs and you see lows. Set a hot glass of water on the counter here and a cold glass of water. Leave them touch and leave them sit there for long enough. They'll both be the same temperature. The energy from the high goes into the low. They'll both be the same. The greater that temperature differential, the more energy that moves. That's why we get strong storms when we have a big high and a big low. All those things are what makes your refrigerator work, what makes a ground source heat pump work. So, a couple things going on here. We have an earth loop, or a source of water. That's where we get our energy from. All the colors around there are representing the freon, or not freon, I'm sorry, the refrigerant that's inside that box, because that's what everyone calls it, is freon. Freon's gone since the 1970s. It now happens to be called R410, but it's a refrigerant. It's a fluid that we can compress and transfer energy. And the squiggly lines here, that's meant to represent the energy in your house. We simulate air, but it can be water. We can have water heat in the house, just no problem. So what happens here? Well, when our refrigerant comes in contact with that earth loop, when we're bringing that water in from outside, the first thing happens in that box is there's a little heat exchanger in there. So when the refrigerant goes by that heat exchanger, the refrigerant's the cooler component, the earth is the warmer component, energy flows downhill, the energy from the earth goes into the refrigerant gets warm. Warm means it absorbed energy. It got a start. Goes into a reversing valve, which we're going to skip for a minute, goes down into the compressor. That compressor is similar to what's in your refrigerator. It's a little bit bigger and a whole lot smarter, but it's a compressor. That compressor's whole job is to squeeze that gas. Anybody still cook with a pressure cooker? That's all a pressure cooker does. You raise the pressure, you raise the temperature. You didn't add any energy, you just squeezed it. Now when we come out of that compressor, we have hot gas. In the thermodynamic sense, it's actually called a superheated gas. Because the very first thing we can do, DHW stands for domestic hot water. First thing we can do is strip a little bit of that energy away, heat your hot water for the house. Take enough energy to heat the hot water, but not enough energy that we still can't heat the house. Now the hot gas travels up, goes into the heat exchanger. Heat exchanger is just basically a big radiator. It's what's in that box right behind that air filter. So we have hot gas going in the top. We have the cooler air circulating through the house. Our same thing, energy flows downhill. The energy from the refrigerant flows into the air or water. The refrigerant cools off, the air warms up. How warm can we make your house? Well, we're probably going to put out about 105 to 110 degree air. So I could probably make your house 85 or 90 degrees with no supplemental heat. Another question come up. So now my refrigerant's given up its energy. It goes down to the circuit. It goes in a thing called an expansion valve. All the expansion valve is the opposite of compressor. What we're trying to do is lose energy now because we're trying to make the gas cool. So when it goes to an expansion valve, the pressure drops. It's like your garden hose when you take the nozzle off, the pressure drops. Same time the pressure drops, it loses energy. It's also the point where it changes what we call changes state. It goes from a gas to a liquid, so that when it goes past that earth loop, it can absorb more energy. Sits there and does it forever. So you've basically taken the heat from the earth, you've transferred into the refrigerant, and from the refrigerant into the house. 3 separate systems circulating. So we heat at your house. Now we want to cool your house. We said we can't make it cold, right? We can only ever move heat. All we're going to do is take the heat and move it the other direction. So, starting at this compressor can only turn one direction. So when the gas comes out of that compressor, it's just as hot as it was before. But now when we hit that domestic hot water, we want to take all we can because we're about to throw the heat away. You now have free hot water. Anytime you're in cooling mode, you have free hot water because we're about to throw the heat away, as we said. So by very definition, when we use a waste product, it's free. So the most efficient way to do this is 2 hot water storage tanks. So when we're producing hot water, we have a place to put it. So once we go past there, the only thing the thermostat did was tell this reversing valve, I want the heat to go that direction now. Now my hot gas goes that way. So when it hits this earth loop, the refrigerant's the hot component. The earth loop didn't change, but it's the cooler component. It absorbs the heat. The heat goes back into the earth. The refrigerant cools off. It goes to an expansion valve that's going the other direction so that when it can go through that heat exchanger, which is now called a condenser because it's in a condensing mode, it's able to absorb the heat out of the house. It's a great dehumidifier too. You are now running a very cold refrigerant through a cooler with warm air blowing across it. A great dehumidifier. How cool can I make your house? Well, we've had one down to 52 degrees by accident, so I'd say that's probably about as low as we can get, low 50s. So, refrigerant goes back to the circuit, keeps going. Heat and cool.